We will now show how to use Clava to integrate ANTAREX tools into your applications. We have developed APIs for ANTAREX tools and technologies. We will show examples for the integration of mARGOt, libvc, examon, memoization, custom precision, and loop splitting approaches. In this example, we will show you how to integrate the mARGOt autotuner into your application with the help of Clava. The example application is a matrix multiplication which has been tiled. This kernel can be parameterized with the values of the tiles. You can see BS1 and BS2. This kernel is called from the main function, and we will use the autotuner to control the values of these block sizes. This is the main aspect. It will generate two files. The first one contains the configuration for the autotuner, and the second contains the initial knowledge base. The aspect has three main steps. First, we generate a configuration file. Then we perform design space exploration, and finally we change the application to call the autotuner API. We use the mARGOt API for Lara in order to specify the configuration of the autotuner. Among other things, we define monitors, knobs, and metrics to measure. The most important pieces of information are the knobs, and we say that we will change the values of BS1 and BS2, the data features, which are the sizes of the matrices, and then the optimization function, in which we state which metrics to minimize and the constraints that it is subjected to. At the end, we build a configuration file. We also use some of this information for the next two steps. In the design space exploration phase, we will generate several variants of the program and then measure the execution time. We select the call to the matrix multiplication kernel and state that this is where we want to make changes and measure the execution time. We define the values of the knobs and the values of the data features. Our tool will automatically generate several variants and test each one of those. For each of the variants, the tool will perform 3 executions and then return the average execution time. Finally, the code generation aspect will once again select the call to the kernel and then insert code that will update the values of the knobs. We will also insert monitoring and logging call. We can now weave the application. We are in the design space exploration step and we are generating the variants. The configuration file has already been written. We will now perform the 3 tests on each of the 4 generated variants. The design space exploration phase is complete and we have written the file with the initial knowledge base. We also performed the code generation part. We can now see the files that have been generated. This is the configuration file. And this is the file with the initial knowledge. Finally, we can see the output code from Clava. We can see the initialization of the framework, and then right before the call to the matrix multiplication, we update the values of BS1 and BS2, taking into account the data features, which are the sizes of the matrices. We will now build the application. We are copying some scripts that will help build the application into the woven folder. We start by downloading mARGOt and building the library based on the configuration file generated. Then we build our own application and link it against the library. We can now run the application, and we can see the effect of the monitoring and logging from mARGOt.